Before we dive in, please remember that all career advice and salary information shared in this presentation is for educational purposes only. Your individual results and career path will depend entirely on your own effort, experience, location, and the current job market. What if I told you there's a hidden door into the tech industry? A door that doesn't require a 4-year computer science degree, a mountain of student debt, or a genius-level understanding of complex algorithms. A door that could lead to a stable 6-figure career, often with the flexibility of remote work. Right now in the United States, there are over 30,000 open jobs looking for one specific skill. A skill that thousands of people, from baristas to project managers to truck drivers, have learned to completely transform their careers. That skill is Selenium Automation Testing. And if you're thinking, Selenium? Automation? That sounds complicated. I want you to stick with me for just a few minutes, because I'm going to demystify it, break it down into plain English, and show you why this isn't just another tech trend. It's one of the most practical, in-demand, and accessible career paths in the American job market today. This isn't about getting rich quick. This is about getting skilled smart. This is your roadmap to a profession that companies are desperately hiring for. So, what on earth is Selenium? Let's forget the technical jargon for a second. Imagine you work for a company like Zillow, the real estate website. Your job is to make sure the website works perfectly for millions of users every single day. Every time the developers add a new feature like a mortgage calculator, or change the color of a button, you have to test everything. You have to log in. You have to search for a house in Boise, Idaho. You have to filter for 3 bedrooms. You have to click on the new mortgage calculator, enter numbers, and make sure the result is correct. You have to do this on Chrome, on Firefox, on your phone, on a tablet. Now imagine doing that 100 times, 1,000 times. It's tedious. It's mind-numbing. And most importantly, you're human. You're going to make mistakes. You might forget a step, or your eyes might glaze over and miss a tiny critical error. An error that could end up costing Zillow millions of dollars in lost customers if it goes live. This is where Selenium comes in. Selenium is not a person. It's a tool. It's like a programmable robot that lives in your computer. Instead of you manually clicking through the website, you write a simple script, a set of instructions that tells Selenium what to do. You write a script that says, open Chrome, go to Zillow.com, type Boise, Idaho into the search bar, click the search button, check that the results page appears. You build this robot, this script one time, and from then on, you can run it 1,000 times a day, and it will perform the exact same test perfectly in seconds. It doesn't get tired. It doesn't get bored. It doesn't miss things. It just executes your commands and gives you a report. Pass or fail. That's it. That's the core of what Selenium Automation is. It's teaching a computer to test software so that humans don't have to. You are the teacher, the puppet master, telling the browser exactly what to do. Now, why is this one skill so valuable? Why are companies willing to pay, on average, over $110,000 a year in the US for people who can do this? The answer is simple: scale, speed, and safety. Let's talk scale. Every business is now a tech business. Your local bank, the grocery store you shop at, the airline you fly with, they all rely on complex web applications to function. Bank of America isn't just a building anymore. It's an app and a website where millions of transactions happen every hour. A tiny bug in their transfer funds feature could be catastrophic. These companies are operating at a massive scale, and they cannot afford to have things break. Manual testing simply cannot keep up. They need an army of automated tests running constantly to protect their business. Next, speed. In today's market, speed is everything. Companies like Netflix and Amazon update their software hundreds, sometimes thousands of times per day. They can't afford to wait 2 weeks for a team of manual testers to check everything. They need to know in minutes if a new piece of code broke something. Automation provides that instant feedback loop. It allows them to innovate faster, release new features with confidence, and stay ahead of the competition. If you can write the scripts that enable this speed, you become an absolutely essential part of the modern technology pipeline. You are the gatekeeper of quality. And finally, safety, or more accurately, cost savings. A software bug is cheap to fix if you catch it early. But a bug that makes it to production that a customer finds, the cost explodes. It's not just the cost of the developer's time to fix it. It's the cost of customer support calls, the cost of lost sales, the cost of damage to the brand's reputation. Remember that time a major airline's website went down during a holiday sale, costing them millions in a single hour? Chances are a bug was the culprit. A bug that a good automated test could have caught. Companies pay six figures for automation engineers because it is an investment. You are their insurance policy against multi-million-dollar failures. Paying you $100,000 to prevent a $10 million disaster is the easiest business decision they'll make all year. This demand isn't theoretical. Go to any major US job board right now. Type in QA Automation Engineer, or SDET, which stands for Software Development Engineer in Test. Look at the companies hiring. They are not just the big tech giants in Silicon Valley. They are banks, insurance companies, retailers, healthcare providers, and government agencies in every single state. From JP Morgan Chase in New York to the Home Depot in Atlanta to United Health Group in Minnesota. These are stable, foundational American companies, and they are all in a desperate search for people who can ensure their technology works. And this brings us to the biggest myths that stop people from even trying to learn this skill. The first and most common is, "I'm not a programmer, I could never do that." Let me be clear. You do have to learn some coding, but you do not need to be a computer science wizard. The level of programming required to write Selenium scripts is fundamentally about logic and problem solving, not complex data structures and algorithms. It's more like learning to write a very specific, detailed recipe. If you can follow instructions and think through a process step by step, you have the foundational mindset for this work. Many of the best automation engineers I know were former teachers, musicians, or even chefs. They excelled because they were detail-oriented and great at breaking down complex problems into small, manageable steps. The second myth is, "I don't have a degree, so no one will hire me." This is becoming less and less true in the tech world every single day, especially for skills-based roles like this. Companies care about one thing. Can you do the job? Can you write the tests that will save them money and protect their brand? If you can build a portfolio of projects that demonstrates your ability to write clean, effective automation scripts, that portfolio will speak louder than any diploma. Your skills, not your credentials, are what get you hired. The final and perhaps most damaging myth is, "I've missed the boat. It's too late to get into tech." The reality is the exact opposite. As our world becomes more digital, the need for quality assurance only grows. With the rise of AI, new applications are being developed faster than ever before, and every single one of them needs to be tested. The demand for ensuring software quality isn't shrinking. It's exploding. You haven't missed the boat. You've arrived just as a whole new fleet is being built, and they need skilled crews. So the opportunity is real. The demand is massive, and the barrier to entry is lower than you think. This isn't just about learning a tool. It's about adopting a new way of thinking, a mindset focused on quality. It's about becoming the person who builds the safety net that allows companies to innovate and grow without fear. Throughout this series, we're going to give you the complete blueprint. We'll cover the core programming concepts you actually need, how to set up your environment, how to write your very first Selenium script, and how to build those scripts into a powerful testing framework that will make your resume irresistible to recruiters. We'll show you how to think like a tester, how to find bugs others miss, and how to prove your value from day one. This is your masterclass. The answer to why companies value this skill so much lies in a simple, powerful concept that drives the entire digital economy. And understanding it is the first real step to claiming your spot in this high-demand field. That concept is the relentless, unforgiving pressure of speed. In the digital world, speed isn't just a feature. It's the entire game. The ability to innovate, update, and deploy new software faster than your competitors is the single greatest predictor of success. But speed has a dark side. Speed creates risk. And managing that risk at scale is the billion-dollar problem that every single tech company in America is trying to solve. This is where you come in. To truly understand this, let's step away from the code for a moment and tell a story. A story that plays out every single day in Silicon Valley, in Austin, in New York, and in countless remote offices across the country. Imagine a small startup. Let's call them Innovate Tech. They have a brilliant idea for a new social media app, ConnectSphere, that helps local artists collaborate. The team is small, just a couple of visionary founders, a handful of brilliant coders, and one incredibly dedicated quality assurance tester. Let's call her Sarah. In the early days, life is a whirlwind of caffeine and creativity. The coders build a new feature like a direct messaging system. They hand it over to Sarah. Her job is to act like a user. She manually clicks every button, types in every field, and tries to break it in every way she can think of. Does the message send? Does it work with emojis? What happens if you try to send a 1,000-page novel? She finds a few bugs, reports them, the coders fix them, and they push the new feature live. It's a slow, methodical process, but with a small app and a small team, it works. The company launches and people love it. Success comes fast. The user base doubles, then quadruples. The investors are thrilled. Now the pressure is on. We need more features, the CEO declares. Let's add video sharing. Let's add a marketplace for artists to sell their work. The coders get to work building furiously. But now, Sarah's job has become exponentially harder. Every time a new feature is added, she doesn't just have to test that new feature. She has to go back and retest everything else to make sure the new code didn't accidentally break something old. Did adding video sharing somehow break the login page? Did the new marketplace code mess up the direct messaging? This process of retesting the entire application is called regression testing. And it is the silent killer of speed and innovation. Think about it like building a skyscraper. When you add the 50th floor, you don't just check the new floor. You have to send inspectors all the way down to the foundation to make sure the whole structure is still sound. For Sarah, her regression suite, the checklist of everything she has to retest, is growing at an alarming rate. What used to take her a day now takes a week. The company hires 2 more manual testers to help her. But even with 3 people clicking, typing, and checking, they can't keep up with the pace of development. A dangerous cycle begins to form. The developers finish a new feature, but it sits in a queue for 2 weeks waiting for Sarah's team to test it. The business leaders get frustrated. Why is everything so slow? Our competitors are launching new features every week. So they make a fateful decision. We can't wait 2 weeks. Let's shorten the testing cycle to 3 days. Now Sarah's team is in an impossible position. They have to test a week's worth of work in just 3 days. They have to cut corners. They focus on the new features and only do a quick superficial check of the old ones. They start missing things. Small bugs at first. A typo here, a misaligned button there. Annoying but not critical. But then the inevitable happens. The team releases a major update with the new artist marketplace. In the rush, they only did a cursory regression test. What they didn't know was that a tiny change in the user profile code created a critical flaw. When a user tried to update their profile picture, it didn't just change their picture. It wiped out their entire portfolio of artwork. The backlash is immediate and catastrophic. Thousands of artists lose years of work in an instant. The app's ratings plummet. Angry users flood social media. The company's reputation is in tatters. The CEO is doing damage control, the investors are furious, and the developers are pulling all-nighters trying to fix the mess. And in the middle of it all is Sarah, feeling the weight of the world on her shoulders, knowing that the process itself was designed to fail. Her team was set up to be the bottleneck, the brakes on a car that everyone else was trying to drive at 200 miles per hour. This story, in various forms, is the fundamental crisis of modern software development. It's the conflict between the need for speed and the demand for quality. You can't sacrifice quality because you'll end up like Innovate Tech, losing customers and trust. But you can't sacrifice speed because your competitors will eat you alive. This is the exact point where companies realize that manual testing is a dead end. It doesn't scale. It's too slow, it's too expensive, and it's prone to human error. You can't solve a problem of exponential complexity by simply throwing more people at it. They realize they don't have a people problem, they have a process problem. They need a way to check that entire skyscraper from the foundation to the penthouse automatically. They need a tireless, precise, and incredibly fast inspector who can run thousands of checks in minutes, not weeks. They need a system that can run the entire regression suite every single time a developer changes a single line of code, providing instant feedback. They need to automate. And this is why the demand for Selenium automation testers has exploded across the United States. Companies like our fictional Innovate Tech are having this exact crisis every single day. They are desperately searching for people who can build these automated checks. They aren't just looking for testers. They are looking for quality engineers. They are looking for software development engineers in test. They are looking for the people who can break the vicious cycle of slow, risky releases. They are looking for the person who can walk into Innovate Tech and say to Sarah and her team, "There is a better way. Let's build a system that tests for us, so you can focus on what humans do best." Exploratory testing, creative problem solving, and ensuring a truly great user experience. The value you provide as a Selenium automation specialist isn't just about finding bugs. It's about enabling speed. It's about reducing risk. It's about saving the company from catastrophic failure. You become the guardian of quality and the enabler of innovation. You are the one who solves the fundamental crisis. Your salary doesn't reflect how many buttons you can click. It reflects the immense business value of preventing a multi-million-dollar disaster. It reflects the competitive advantage you give a company by allowing them to release new features with confidence and with speed. This is why a six-figure salary isn't just possible. It's the industry standard for someone who can solve this high-stakes problem. So now we understand the why. We've seen the pain, the chaos that comes from trying to build 21st century software with a 20th century process. We understand the strategic importance of automation. The question is no longer if a company should automate, but how. And to answer that, we need to look at the specific tool that became the gold standard for the entire industry, the tool that powers the testing frameworks of giants like Google, Netflix, and Amazon. The tool that will become the foundation of your new career. That tool is called Selenium, and the story of how it came to be isn't just a piece of tech trivia. It's a perfect lesson in how the most valuable skills are born from solving a real, frustrating problem. To understand why Selenium dominates the US job market, you have to understand where it came from. Our story begins in 2004. Picture the tech landscape back then. The iPhone doesn't exist yet. Facebook is a tiny network just for college students. The web is a different world. And inside a cutting-edge software consultancy called ThoughtWorks, an engineer named Jason Huggins is facing a problem that would be familiar to anyone in software development. He was working on a new internal application for tracking time and expenses, and like any good engineer, he had to test it over and over and over again. Every time a developer made a small change to the code, Jason or someone on his team had to manually go through the entire application. Log in, click this button, fill out this form, submit it, check the result, log out, then do it all again on a different web browser. It was mind-numbing, soul-crushing, repetitive work. It was slow, it was expensive, and worst of all, it was prone to human error. After the 100th time you've checked the same login form, your brain starts to turn to mush. You miss things. Jason knew there had to be a better way. He thought, I'm a programmer. The browser is just a program. Why can't I write a program to control the program? He realized that he could use a simple, lightweight language that already lived inside every web browser: JavaScript. He created a clever piece of JavaScript code that could automatically simulate a user's actions. It could click buttons, type text into fields, and navigate between pages, all driven by a script. He called it the JavaScript Test Runner. It was a simple tool built to scratch his own itch, to save himself from the excruciating boredom of manual testing. But something amazing happened. Other engineers at ThoughtWorks saw what he had built and they wanted it badly. They were all facing the same problem. This little internal tool started spreading like wildfire throughout the company. It was saving teams hundreds of hours of manual labor. Jason and his team realized they had stumbled onto something much bigger than a simple time-tracking app tester. They had created a new way to ensure software quality. So in a move that would define its future and cement its legacy, they made a critical decision. They decided to make it open source. They released the code to the world for free. They believed this technology was too important to be locked away inside one company. And as they prepared for the public release, Jason needed a better name than JavaScript Test Runner. At the time, the dominant player in the automated testing market was a company called Mercury Interactive, which sold an expensive proprietary tool. In a moment of inspiration, Jason made a joke. In chemistry, selenium is a chemical element that is known to be a potent antidote to mercury poisoning. He thought, what better name for a free open-source tool that was going to be the antidote to the expensive, closed-off market leader? The name stuck. Selenium was born. But this first version of Selenium, which we now call Selenium Core, had a major weakness. A fatal flaw, really, that was built into the very fabric of the internet for security reasons. It's called the same origin policy. Think of it like this. Imagine your web browser is a secure apartment building. The same origin policy is the security guard at the front desk. This guard says that a script from one apartment, let's say apartmenta.com, is only allowed to access information and resources inside apartmenta.com. It can't go snooping around in apartmentb.com or apartmentc.com. This is a crucial security feature. It's what stops a script on a malicious website from stealing your login information from your online banking tab. Selenium Core, being a JavaScript program, was bound by this rule. This meant your test script had to be hosted on the exact same server as the application you were trying to test. For Jason's internal time tracking app, this was fine. But for testing complex, real-world applications that pull resources from dozens of different domains, it was a nightmare. This limitation severely hampered its usefulness. The story could have ended there. A brilliant idea, limited by the fundamental security rules of the web. But another engineer at ThoughtWorks, Paul Hamant, saw the potential. He saw what Selenium could be if they could just get around this one problem. And he came up with an ingenious solution. He created a server that would act as a middleman, a proxy. This proxy would sit between your test script and the web browser. When you ran your test, the browser wouldn't talk to your script directly. Instead, it would talk to the proxy server. The proxy would then fetch the web application you wanted to test and inject the Selenium core JavaScript into it. From the browser's perspective, both the application and the test script were coming from the same place, the proxy server. The same origin policy was satisfied. It was a brilliant workaround. This new tool was called Selenium Remote Control, or Selenium RC. And this changed everything. With Selenium RC, you could now write your tests in any popular programming language you wanted: Java, C#, Python, Ruby, you name it. Your test script would send commands to the Selenium RC server, and the server would translate those commands and pass them along to the browser. Suddenly, Selenium wasn't just a JavaScript library anymore. It was a true language-agnostic, cross-browser automation framework. You could write one test in Python and run it on Internet Explorer on a Windows machine, then on Firefox on a Mac, and then on Chrome on a Linux box, all without changing a single line of your test code. This was revolutionary. It was the holy grail for testers and developers. The open source community exploded. Contributions poured in from all over the world. But the evolution wasn't over. While Selenium RC was taking the world by storm, another engineer named Simon Stewart, then at Google, was working on his own browser automation project in 2006. He called it WebDriver. Simon had a different philosophy. Selenium RC, for all its brilliance, was essentially tricking the browser. It worked by injecting a massive block of JavaScript into the application and using that JavaScript to simulate user events. It was like a puppeteer pulling strings from above. WebDriver had a different goal. It wanted to control the browser natively. Instead of injecting JavaScript, WebDriver aimed to use the browser's own internal automation APIs, the same hooks that the browser's own developers used for their testing. This was like the puppeteer putting their hand directly inside the puppet. The control was more direct, more realistic, and much faster. It didn't have the same origin policy problem, because it wasn't relying on JavaScript injection. Each browser, Chrome, Firefox, Internet Explorer, would have its own specific driver, a small executable file that acted as a translator between the WebDriver commands and that browser's native controls. For a time, these two brilliant projects, Selenium RC and WebDriver, existed in parallel. They were competitors, in a sense, both trying to solve the same problem with different approaches. But in a move that speaks volumes about the collaborative spirit of the open source community, the two teams decided to join forces. They realized that Selenium RC had the massive community and the powerful remote control server, while WebDriver had the more modern, stable, and faster browser control technology. In 2009, they announced they would merge the two projects. The result was Selenium 2.0, more commonly known today as Selenium WebDriver. It combined the best of both worlds, the power and flexibility of the original Selenium with the speed and stability of WebDriver's native approach. This is the Selenium that is the standard in the industry today. And they added one more crucial piece to the puzzle: Selenium Grid. As companies like Google and Facebook started building massive test suites with thousands, or even tens of thousands of automated tests, they ran into a new problem: speed. Running 10,000 tests one after another could take days. Selenium Grid was the answer. It allowed you to create a network of machines, Windows, Mac, Linux, all running different browsers. Then you could send your entire test suite to the grid, and it would intelligently distribute the tests to run in parallel across all those machines at once. A test run that took 24 hours could now be completed in 15 minutes. So you see, Selenium isn't just a tool that someone built one day. It's an evolution. It's a story of brilliant engineers confronting real-world limitations, boredom, security policies, speed, and building ingenious solutions, layer by layer. It's a testament to the power of open-source collaboration. This history is baked into its DNA. It's why it's so robust, so flexible, and so trusted by every major tech company on the planet. And it's why understanding its components is the key to unlocking its power for your career. So let's turn that key. Let's unlock that power, piece by piece. When most people hear Selenium, They think it's a single thing, one program you download and run. But that's like saying a mechanic's toolbox is a single tool. It's not. It's a collection, a suite of powerful, specialized instruments, each designed for a specific job. Understanding the difference between these tools isn't just trivia. It's the line between a junior tester who can follow a script and a senior automation engineer who can build a testing fortress from the ground up. This is the knowledge that gets you hired for the high-paying roles. The Selenium project is really a family of three main components: Selenium WebDriver, Selenium IDE, and Selenium Grid. Think of them as the heart, the hands, and the nervous system of web automation. And the undisputed heart, the core engine that powers everything, is Selenium WebDriver. If you remember only one thing from this entire video, let it be this. When a US job description lists Selenium experience as a requirement 99% of the time, they are talking about Selenium WebDriver. This is the powerhouse. This is the main event. WebDriver isn't a clunky program with a big user interface. It's an API, an application programming interface. Now, don't let that acronym scare you. Think of an API as a universal translator. It allows your code, whether you write it in Java, Python, C# or another language, to speak directly to a web browser in its native language. Older automation tools worked like a puppet master pulling strings from the outside. They would simulate mouse clicks and keyboard presses at the operating system level. It was slow, it was brittle, and if you so much as moved your mouse during a test, the whole thing could fall apart. WebDriver changed the game completely. It doesn't pretend to be a user. It hooks directly into the browser's own automation controls. It's not sending a signal that says, "Pretend to click here." It's sending a command that the browser understands natively, telling it, "Find this button element and execute your internal click function on it." The difference is monumental. It's the difference between shouting instructions at someone across a noisy room using hand signals versus having a direct, clear-as-day phone call with them. This direct line of communication makes WebDriver incredibly fast, incredibly stable, and unbelievably powerful. It can do anything a real user can do and much more. It can navigate, fill out forms, click buttons, drag and drop elements, execute JavaScript, take screenshots, and inspect every single piece of the web page's code. And because it speaks the native language of each browser, it can do this consistently across Chrome, Firefox, Safari, Edge, you name it. This cross-browser capability is a cornerstone of modern software development, and WebDriver is the key that unlocks it. Mastering WebDriver is mastering the core skill that companies are desperate to hire for. It's where you'll spend the vast majority of your time as an automation engineer, writing clean, robust, and reusable code that drives the browser with surgical precision. Now, if WebDriver is the powerful industrial-grade heart of the system, then the second component, Selenium IDE, is the friendly, approachable set of hands. The IDE, which stands for Integrated Development Environment, is a simple browser extension. A little button you add to Chrome or Firefox. Its primary function is record and playback. You press record, you click around a website like a normal user, you log in, you search for a product, you add it to your cart, and the IDE watches everything you do. It translates your actions into a basic Selenium script. When you're done, you can press play, and it will repeat those exact steps automatically. For a beginner, this feels like magic. And it is. It's an incredible way to get your first taste of automation without writing a single line of code. It's the perfect entry point, the tool that lets you see the potential of automation in seconds. You can use it to create very simple, quick and dirty tests to check if a login page is still working, or to automate a boring, repetitive task you have to do every day. But, and this is a critical distinction that will set you apart in an interview, the Selenium IDE is not the tool you use to build an enterprise-grade automation framework for a Fortune 500 company. Its record and playback scripts are notoriously brittle. If a developer changes the ID of a button or slightly rearranges the page layout, your recorded script will break. It doesn't handle complex logic, conditional statements, or dynamic data very well. Think of it like this: the IDE is like a microwave meal. It's fast, it's easy, and it gets the job done for a simple need. But you're not going to become a Michelin star chef by only using a microwave. WebDriver is learning to cook from scratch. It requires more skill, more practice, and a deeper understanding of the ingredients, the code, but it allows you to create anything you can imagine, a solution that's robust, scalable, and can handle any complexity thrown at it. A smart engineer knows when to use the microwave for a quick snack and when to fire up the full kitchen. They use the IDE for quick prototypes or to help generate boilerplate code, but they build the real, lasting solution with WebDriver. So we have the heart WebDriver for writing powerful code-based tests. We have the hands, the IDE for quick recording and simple tasks. But what happens when your application needs to be tested on Windows with Chrome, on a Mac with Safari, and on Linux with Firefox all at the same time? What happens when you have a suite of 500 tests that, if run one after another, would take 6 hours to complete, 6 hours where your developers are just waiting for feedback? Running tests sequentially is a bottleneck. It slows down development and costs the company money. This is where the third and final component comes in. The nervous system that connects everything and multiplies its power, Selenium Grid. Selenium Grid is not a testing tool itself. It's a scaling tool. It takes your single WebDriver script and allows you to run it simultaneously across dozens, or even hundreds, of different machine and browser combinations in parallel. Imagine a single toll booth on a 10-lane highway at rush hour. The traffic is going to back up for miles. That's running your tests one by one. Selenium Grid is like opening all 10 toll booths at once. The traffic flows through instantly. Here's how it works. You set up a central hub machine. Then you connect multiple node machines to it. These nodes can be different physical computers or virtual machines in the cloud. One node could be a Windows 11 machine running the latest version of Edge. Another could be a Mac running Safari. A third could be a Linux machine running an older version of Firefox to check for backward compatibility. When you're ready to test, you send your WebDriver script to the Grid's hub. The hub sees the script, looks at all its available nodes and says, "Okay, I have a free Windows machine, run the test there. I also have a free Mac. Run the same test there simultaneously." Suddenly, your 6-hour test suite is finished in under 20 minutes. The feedback loop for your development team shrinks from hours to minutes. They can find and fix bugs faster. They can release new features with more confidence, and the entire company can innovate at a much higher velocity. This is the kind of business impact that gets you promoted. Understanding Selenium Grid demonstrates that you're not just thinking about writing a single test. You're thinking about efficiency, scalability, and the entire software development lifecycle. You understand how to build a testing infrastructure that supports a fast-moving modern tech company. So there you have it. The Selenium trifecta. WebDriver, the powerful core API for writing your tests in code. The IDE, the simple browser extension for quick record and playback. And the Grid, the intelligent router for running your WebDriver tests at massive scale across different environments. They are not competing tools. They are a complementary suite. You write the intelligence with WebDriver, and you scale it with Grid. Knowing how each piece fits into the puzzle is the foundation of true Selenium mastery, and it's what separates the applicants from the hires. So now that you understand the big picture, WebDriver as the brain, Grid as the muscle, we arrive at the most critical, and often the most debated question a new automation engineer has to ask themselves: what language do I use to speak to the machine? This isn't just a technical choice. It's a career-defining decision. Choosing the right programming language for Selenium is like a craftsman choosing between a sledgehammer and a surgical scalpel. Both are tools, but using the wrong one for the job can lead to frustration, failure, and a whole lot of wasted time. Let me tell you about a guy I mentored. Let's call him Kevin. Kevin was sharp. He understood testing logic inside and out. He devoured tutorials on Selenium, learned all about locators, weights, and the page object model. He chose to learn Python because he read online that it was easy and fast. And he was right. He was writing scripts in a matter of weeks. He felt ready. He landed an interview at a major financial institution in New York, a dream job with a 6-figure salary. He walked in confident. The technical interview started, and the lead engineer slid a laptop over to him. "All right," the engineer said. "We use a Java and test into framework here. Can you walk us through how you'd add a new test for our login validation?" Kevin froze. Java? TestNG? He had never even looked at it. All his knowledge, all his practice was in a language they didn't use. He couldn't translate his Pythonic thinking into Java syntax on the fly. He stumbled, he struggled, and he didn't get the job. Kevin's mistake wasn't learning Python. His mistake was not understanding the landscape of the US job market before he chose his weapon. This is the crossroad where so many aspiring engineers get lost. So let's clear the fog. We're going to break down the big three, the dominant languages for Selenium in the United States: Java, Python, and JavaScript. First, let's talk about the undisputed king, the reigning heavyweight champion, Java. Selenium itself was originally written in Java. They grew up together. This means the support for Java in the Selenium ecosystem is unparalleled. It's the most mature, most stable, and most documented binding. When a new Selenium feature is released, you can bet your bottom dollar the Java implementation is rock solid from day one. Why do big companies love Java for test automation? 3 words: structure, scalability, and stability. Java is a statically typed language, which sounds intimidating, but it just means you have to be very explicit about your code. The compiler catches errors before you even run your tests, which in a massive complex test suite with hundreds of thousands of lines of code, is an absolute lifesaver. Think about the companies that can't afford for things to break: banks, insurance companies, healthcare providers, government contractors. They run on Java. Their applications are built in Java, their developers speak Java, so it's a no-brainer to build their testing frameworks in Java. When you pair it with build tools like Maven or Gradle, and testing frameworks like TestNG or JUnit, you have an enterprise-grade automation machine. If your goal is to walk into a Fortune 500 company, a major bank on Wall Street, or a legacy tech giant and command a top-tier salary, learning Selenium with Java is the safest, most reliable path to get there. It's the blue-chip stock of automation languages. But then there's the challenger, the quick, agile, and incredibly popular upstart, Python. If Java is the corporate battleship, Python is the nimble fleet of speedboats. The number one reason people flock to Python is its readability and simplicity. Python code often looks like plain English. What takes 10 lines of code in Java can often be done in 3 or 4 lines in Python. This means faster development, easier maintenance, and a much gentler learning curve for beginners. Where does Python dominate? The startup world. Silicon Valley and other tech hubs are built on the principle of moving fast and breaking things. Python's speed of development is perfect for this agile environment. Companies that are heavily invested in data science, machine learning, and artificial intelligence also live and breathe Python. So if you're looking at a job posting from a trendy tech startup, a data analytics firm, or even tech giants like Google and Instagram, you will see Python listed as a requirement far more often. The community is vibrant, and frameworks like PyTest are incredibly powerful and elegant. Learning Python with Selenium positions you as a modern, versatile engineer who can get things done quickly and efficiently. It's the language of innovation. So we have the corporate king, Java, and the agile challenger, Python. But there's a third, incredibly logical player in this game: JavaScript. Think about it for a second. What are we testing with Selenium? Web applications. What is the native language of the web browser? JavaScript. There's a beautiful symmetry to using the language of the application to test the application itself. For years, JavaScript Selenium bindings were a bit clunky, but that has changed dramatically. With the rise of modern frameworks like Node.js, and powerful test runners like WebDriver.io and Jest, JavaScript has become a first-class citizen in the automation world. The biggest advantage? It bridges the gap between developers and testers. If you're on a team where the front-end developers are writing in React, Angular, or Vue.js, and you, the automation engineer, also write your tests in JavaScript, the collaboration is seamless. You can share code, understand each other's work, and break down the traditional silos. This is huge for companies embracing DevOps and shift-left testing philosophies. A person who can write front-end code and automate tests for it in the same language is not just a tester. They're a full-stack automation powerhouse. This makes you incredibly valuable, especially in roles that blur the lines between development and quality assurance. So which one do you choose? This is where we circle back to Kevin. His problem wasn't his choice, but his lack of strategy. The answer isn't about which language is best. The answer is, which language is best for your career goals? Stop and ask yourself, what kind of company do I want to work for in 2 years? Do you see yourself ensuring the stability of a major banking application? Go with Java. Do you dream of working at a fast-paced startup building the next big thing? Python is your ticket. Are you passionate about the front end and want to be a deeply integrated member of a modern development team? JavaScript is your path. Look at the job descriptions in your city for the companies you admire. Don't just look at one. Look at 20. Look at 50. A pattern will emerge. The market will tell you what it wants. Your local job market is the ultimate source of truth. And here's the most important secret of all, the one that should give you a massive confidence boost. The language is just syntax. It's the vehicle. The actual skill, the art of automation, lies in the concepts. Understanding how to find elements on a page, how to handle timing issues with weights, how to design a scalable framework using the page object model. These principles are universal. Once you master them in one language, learning a second or third is 10 times easier. A great engineer isn't someone who just knows Java or just knows Python. A great engineer is someone who understands the principles of automation so deeply that they can pick up the necessary tool for the job. Kevin eventually learned this. After that failed interview, he didn't give up. He buckled down and spent a few months learning the fundamentals of Java. He didn't become a Java expert, but he became proficient enough to translate his Python knowledge. His next interview was at another large corporation. They used Java. This time he was ready. He got the job. A year later, a new project came up that was a perfect fit for Python's data handling capabilities. Guess who was chosen to lead the automation effort for that project? Kevin. He wasn't the Python guy or the Java guy anymore. He was the automation guy. That's the ultimate goal. Don't just learn a language. Learn the craft. Start with the language that aligns with your immediate career goals, but never stop being curious. Because that's what truly makes you a high-demand, indispensable asset in the US job market. Now you've chosen your path. You've picked your language, whether it's the stable power of Java, the agile speed of Python, or the native elegance of JavaScript. You've set up your development environment. You open your code editor, stare at that blinking cursor on a blank file, and a wave of panic hits you. Where do I even begin? What are the first words I need to type to bring the browser to life? In the next part, we're going to banish that fear forever. We will write our very first fully functional Selenium script from scratch line by line, and I promise you by the end of it you'll feel like a magician. Alright, the stage is set. The tools are laid out on our digital workbench. Your code editor, your integrated development environment or IDE, this is your spellbook. It's where we will write the incantations that command the digital world. The programming language we're using, let's stick with Python for its beautiful, clean syntax. That's the ancient tongue we'll use to speak our commands. And Selenium WebDriver? That is the magic wand. It's the conduit that channels our intent from this spellbook directly into the browser. So let's open that spellbook. Create a new blank file. Name it something like first_test.py. The .py is important. It tells the system we're speaking Python. Now, every great magic system has rules. It has foundational principles. In our world, the first rule is that you can't use a spell you haven't learned. We need to tell our script which magical libraries, which schools of magic we intend to draw from. We do this with import statements at the very top of our file. The first thing we need is Selenium itself, specifically the WebDriver component. So the first line we'll type is, from Selenium import WebDriver. This is like saying, I am going to perform magic that controls a web browser. Simple as that. Next, we need a way to tell Selenium how to find things on a web page. Are we looking for something by its unique name, its type, its location? Selenium has a built-in tool for this, a kind of magical targeting system. We need to import it. So, on the next line we'll write from selenium.webdriver.com and .by import by. The by class is our universal translator for locating elements. Think of it as a magical index allowing us to say find by ID, find by name, find by path, and so on. We're preparing our tools. And for this first script we'll need one more tool. We want to be able to press keys on the keyboard like the Enter key to submit a search. So we'll add a third import, from selenium.webdriver.com and .keys import keys. This gives us access to a list of non-text keys like Enter, Tab, Shift, and the arrow keys. That's it. 3 lines. That's our entire magical preparation. WebDriver, by, and keys. With these 3 imports, we have everything we need to perform our first feat of automation. Now for the moment of truth. The summoning. This is the part that feels like real magic. We are about to conjure a brand new, clean, controllable browser window out of thin air. To do this, we need to create an instance of our WebDriver. We'll assign it to a variable, which is just a name we can use to refer to it later. A common convention is to simply call it driver. So the next line of code is driver equals WebDriver. Chrome. Let's break that down. We're saying, hey WebDriver that we imported, I want to use the Chrome browser. And we're storing that newly created, living, breathing browser session in our variable called driver. From this moment on, anytime we want to talk to that specific browser window, we just talk to driver. It is our loyal automated servant. If you were to run the script right now, with just these 4 lines, something incredible would happen. A Chrome browser window would pop into existence on your screen. It would be completely blank, and it would say Chrome is being controlled by automated test software. That message is the proof. It's Selenium whispering to you. I'm here. I'm listening. What is your command? Okay, our servant has been summoned. Now we must give it its first task. Let's send it to a destination. The command for this is beautifully simple. Get. We tell our driver to get a web page. So the next line is driver.get https://www.google.com. We're issuing a direct order. Driver, go to this specific web address. When the script runs, you'll see that browser window, which was once blank, instantly navigate to the Google homepage. The speed is startling. No typing, no clicking bookmarks. Just a direct command and instant execution. This is the first taste of real power. But just visiting a page is passive. We want to interact. We want to do something. Let's use Google for what it's for, searching. To do that, a human would look for the search bar and click on it. We need to do the same but with code. We need to tell our driver, find the search input field on this page. This is where our by import comes into play. We need to find a unique identifier for that search bar. If you go to Google and use your browser's developer tools to inspect the search bar element, you'll find it has several attributes. One of them is a name attribute, and its value is simply the letter Q for query. That's perfect. It's simple and likely to be stable. So we'll tell our driver to find an element by .name, and the name we're looking for is Q. The code looks like this. Search_box equals driver.find_element by .name, Q. Let's dissect this incantation. We're telling our driver to find _element. What kind of element? We specify the strategy first by .name. Then we provide the value for that strategy, Q. Selenium will now scan the entire page's source code in a fraction of a second. Find the one element that has name equals Q, and hand it over to us. We're storing that element in a new variable called search_box. We now have a direct, magical link to that specific input field on the page. We've found it. Now what? We want to type in it. The command for this is, again, wonderfully intuitive. It's called send_keys. It does exactly what it sounds like. It sends keystrokes to the element. Our next line will be search_box.send_keys, Selenium Automation. Notice we're talking to search_box now, not driver. We're giving a command to the specific element we found. We're telling it, take these characters, Selenium Automation, and type them into yourself. When the script runs, you will see those words appear in the Google search bar, typed faster than any human could manage. We've typed our search query. What's the final step? We hit enter. This is where our keys import becomes useful. We want to send one more key after our search term, the enter key, so we can simply add it to our send_keys command. The line becomes search_box.send_keys, Selenium Automation, plus keys.return. We're sending our text, and then we're concatenating, we're adding the special keys.return command, which is Selenium's way of saying press the enter key. Some people call it keys.enter, it's the same thing. This single line types our query and submits the search, all in one go. At this point, the browser will have navigated to the search results page. Our job is done, but a good magician always cleans up their workspace. We summoned a browser window. We can't just leave it hanging around. It's consuming memory and resources. We need to dismiss it. The final command is driver.quit. This command doesn't just close the tab or the window. It completely shuts down the WebDriver session, closes all associated windows, and releases the memory. It's the clean, professional way to end your script. And that's it. That is our entire spell. Let's look at the complete scroll all together. From Selenium import WebDriver. From selenium.webdriver.com and UPY import by. From selenium.webdriver.com and .keys import keys. Driver equals WebDriver. Chrome. Driver.get. https://www.google.com. Search_box equals driver.find_element by .name. Q. Search_box.send_keys. Selenium Automation. Plus keys.return. Driver.quit. Just 8 lines of code. 8 lines that summon a browser, navigate to the world's most popular website, find the search bar, type a query, submit it, and then vanish without a trace. Now I want you to run it. Execute that file. And don't blink. For a brief, glorious second, you will see a Chrome window appear. You'll see it load Google. You'll see Selenium Automation flash into the search box. The page will change to the search results. And then, just as quickly as it appeared, the window will vanish. The whole thing might take 2 seconds, but in those 2 seconds you did it. You wrote a program that controlled a web browser. You automated a human task. You wrote your first Selenium script. You just performed your first piece of real, tangible magic. Feel that? That little spark? That's the feeling of control, of automation, of bending the web to your will. But this is just the beginning. Our spell worked, yes, but it was simple. It was also fragile. It relies on a perfect, instantaneous world. What happens if the internet is slow? What if the search box takes a few seconds to load? Our script would try to find it, it wouldn't be there yet. And the entire spell would shatter into a million pieces, throwing a big, ugly no such element exception. Our magic is powerful, but it's not yet wise. It doesn't know how to wait. It doesn't know how to be patient. And in the world of web automation, patience isn't just a virtue. It's an absolute necessity. How do we teach our script to wait for the right moment, to be resilient, to handle the unpredictable, messy reality of the live web? That's the next level of mastery, and it's exactly where we're headed next. Our script, in its current state, is like a hyper-caffeinated intern on their first day. It's eager, it's fast, but it has no sense of timing. Clicks on things before they've loaded. It tries to enter text into fields that don't exist yet. It barrels through the user journey, assuming the website can keep up with its machine-like speed. But the web is not a machine in the same way. It's a living, breathing, and often frustratingly slow ecosystem. This mismatch, this race between our script's speed and the web's reality, is the #1 cause of what we call flaky tests. Tests that pass sometimes, fail other times for no apparent reason. They erode trust, they waste time, and they are the bane of every automation engineer's existence. So how do we fix it? The first instinct, the one every beginner has, is to just tell the script to stop, to pause. In Java, this is thread.sleep. You literally tell your program to go to sleep for a set number of seconds. Let's say a pop-up usually takes about 3 seconds to appear. So you write thread.sleep 3000, and it works. The script pauses for 3 seconds, the pop-up appears, the script finds it, and the test passes. You feel like a genius, but you've just planted a time bomb in your own code. This is what's called a static or a hard-coded wait. And it is, without a doubt, the worst possible way to handle timing issues. Why? What if your network is fast that day, and the pop-up appears in half a second? Your script is still forced to sit there, twiddling its thumbs for the full 3 seconds. You've just wasted 2.5 seconds. Now multiply that by 100 tests, each with a few of these pauses. Suddenly your test suite, which should take 5 minutes, now takes 15. You've single-handedly slowed down your entire development pipeline. But it gets worse. What if the server is under heavy load? What if you're testing a big e-commerce drop, and that pop-up now takes 5 seconds to appear? Your script wakes up after 3 seconds, looks for the pop-up, doesn't find it, and crashes. The test fails. You've created a test that is both inefficient and unreliable. Using thread.sleep is like using a sledgehammer to hang a picture frame. It's a sign of an amateur, a red flag in any code review, and something you should actively avoid. So we need a smarter way. We need to teach our script not just to wait, but to wait intelligently. This brings us to the first real tool in our arsenal, the implicit wait. An implicit wait is a global setting. You define it once, at the beginning of your script when you initialize your WebDriver. You might say something like driver.manage.timeouts.implicitly wait 10 timeunit.seconds. What does this do? It sets a universal rule for your entire script. From this point forward, anytime your script tries to find an element using findElement, it won't fail immediately if the element isn't there. Instead, it will poll the web page over and over again for up to 10 seconds waiting for that element to appear. If it appears after 2 seconds, great. The script moves on immediately. It doesn't waste the other 8 seconds. If it doesn't appear after the full 10 seconds, only then will it throw the no such element exception. This is a massive improvement over the sledgehammer of thread.sleep. It's dynamic. It adapts to the current speed of the application. It makes our tests far more resilient and efficient. For many simple websites and applications, an implicit wait is all you might need to create a reasonably stable test suite. It's the set-it-and-forget-it approach to synchronization. But it has a crucial weakness. The implicit wait only cares about one single condition. Is the element present in the document object model, the DOM? Is it there? It doesn't care if the element is visible. It doesn't care if it's clickable. It doesn't care if it's enabled. Imagine a scenario. You're testing an online form. You select your state from a drop-down menu, and based on that selection, a second drop-down for city is populated via a background AJAX call. The city drop-down element might be present in the HTML from the very beginning, but it's disabled and empty. Your implicit wait when looking for the city drop-down will find it instantly and move on. The script then tries to click on this disabled element and boom, the test fails. The implicit wait wasn't smart enough to understand the state of the element. It only understood its existence. This is where the professionals separate themselves. This is where we move from broad, general rules to precise surgical actions. This is the domain of the explicit wait. An explicit wait is not a global setting. It is a piece of code you write to wait for a specific condition to be met before proceeding to the next step. It's like telling your script, don't just wait for this button to exist. I want you to wait until this button is fully rendered, visible on the screen and clickable. Only then are you allowed to click it. You achieve this using two key components in Selenium: WebDriver wait and expected conditions. You create an instance of WebDriver wait, telling it how long you're willing to wait, say 15 seconds. Then you tell it what specific condition it's waiting for. And Selenium provides a huge library of these expected conditions. You can wait for an element to be visible. You can wait for an element to be clickable. You can wait for an alert to pop up. You can wait for the page title to contain a certain word. You can wait for an element's text to change. Let's go back to our e-commerce flash sale example. The Add to Cart button is on the page, but it's grayed out, it's disabled until you select a size. An implicit wait would find the button and fail. A hard-coded thread.sleep might work, or it might not. But an explicit wait? We would write, wait until expected conditions.element to be clickable, add to cart button. Now our script is intelligent. It will poll and check that button, not just for its existence, but for its clickability. It will wait patiently for up to our defined timeout as the website does its thing. The moment the button becomes active, the script clicks it and moves on. If it never becomes active within the timeout, the test fails, but it fails for the right reason with a clear error message. Timed out waiting for element to be clickable. This is a test you can trust. This is how you build a robust, reliable automation suite that provides real value. This level of granular control is a game changer. But what if you need even more? What if you're dealing with a hyperdynamic web application where elements are constantly appearing, disappearing, and changing, and sometimes a specific harmless error pops up during the loading process that you want to ignore? For these most challenging scenarios, we have one more level: the fluent wait. A fluent wait is essentially an explicit wait on steroids. It gives you ultimate control over the waiting mechanism. With a fluent wait, you can define not only the total timeout but also the polling frequency. Instead of letting Selenium check every 500 milliseconds by default, you could say, check for this element every 100 milliseconds. This is crucial for timing-sensitive operations. Even more powerfully, you can tell a fluent wait to ignore specific types of exceptions while it's waiting. Let's say while waiting for an element, the DOM sometimes refreshes and for a split second, you get a stale element reference exception. Normally, this would crash your explicit wait. But with a fluent wait, you can say, hey, while you're waiting, if you happen to see a stale element reference exception, just ignore it and keep trying until the timeout. The fluent wait is the special forces operator of synchronization. It's for the most complex, hostile, and unpredictable web environments. It's the tool you pull out when you need to build a test that is absolutely bulletproof against the chaos of modern, AJAX-heavy front ends. Understanding the difference between these waiting strategies, the bad, the good, the great, and the expert level, is fundamental to becoming a successful automation engineer. It's the core skill that transforms your scripts from brittle, flaky liabilities into reliable, trustworthy assets. It's the knowledge that allows you to walk into an interview and explain not just what you do, but why you do it, demonstrating a deep understanding of the problems that companies are willing to pay top dollar to solve. You're no longer just writing code that finds elements. You're architecting a testing solution that understands and respects the fourth dimension of the web time. But what happens when the element we're looking for isn't just slow to load, but is trapped? What if it's locked away inside a different context on the page, like an embedded frame for a payment gateway or a pop-up ad? What if our user journey forces open a completely new browser window or tab? Our driver by default only sees the main page. It's blind to these other worlds. We've taught our script patience, but now we need to teach it how to see beyond its immediate surroundings, to navigate the complex, multi-layered structure of a modern web page. To do this, we need to give our script a new command, a new power, the ability to change its context to shift its focus. Let's start with those windows within a window, which in the world of web development are called iframes. An iframe or inline frame is essentially one web page embedded inside another. Think about it. You're reading a news article and there's a YouTube video embedded right in the middle of the text. That video player? That's an iframe. It's a completely separate web page with its own HTML, its own elements, its own world, all neatly packaged and displayed inside the main news article page. Or you're on a small business's website, and you see a Google map showing their location. That map is another web page, another document living inside the parent page. The most critical example for us in testing is payment processing. When you go to buy something online and you get to the part where you enter your credit card number, expiration date, and CVC code, those fields are very often inside an iframe. This is done for security. The e-commerce site you're on doesn't want to handle your sensitive credit card data directly. So they use a trusted payment processor like Stripe or Braintree, who provide a secure iframe. The main site essentially says, I'm going to carve out this little rectangle on my page, and let Stripe handle everything that happens inside it. Now here's the problem for Selenium. When your script loads the checkout page, its focus, its entire reality is the main HTML document. It sees the checkout title, the summary of your cart, the place order button. But when it looks at that rectangle where the credit card fields are, it sees only the iframe tag itself. It's like looking at a building from the outside. You can see the building, you can see the windows, but you have no idea what's inside the rooms. If you tell Selenium, find the element with the ID credit card number, it will search the entire main page and find nothing. It will fail, throwing that frustrating no such element exception, even though you're staring right at the field on your screen. Your script is blind to the contents of that iframe. So how do we give it sight? We have to tell it to walk through the door. We use a command called driver.switchTo.frame. This command is our key. It tells Selenium, pause everything you're doing on this main page, and shift your entire focus into this specific iframe. From now on until I tell you otherwise, you can only see and interact with what's inside this frame. There are a few ways to tell Selenium which frame to switch to. You could use its index number, like switchTo.frame0, for the first iframe on the page. This is simple, but it's brittle. What if a developer adds a new, invisible iframe for an ad at the top of the page tomorrow? Suddenly the payment iframe is no longer index 0, it's index 1, and your script breaks. A much better way is to use the iframe's name or ID. If it has one like switchTo.frame, payment gateway iframe. This is more reliable because those names are less likely to change. But the most robust method is to first find the iframe as a web element itself, and then pass that element into the switch command. You'd say web element payment frame equals driver.findElement by .css selector, iframe.stripe frame, and then driver.switchTo.frame payment frame. This is the professional's choice because it lets you use any powerful locator strategy to pinpoint the exact iframe you need, regardless of its position or ID. Once you've switched, it's like you've entered a new dimension. Now, when you run find element for credit card number, Selenium finds it instantly. You can type in the numbers, you can find the CVC field, you can click the submit button inside the iframe. You've successfully automated the interaction. But then a new problem arises. After submitting the payment, the main page might display a "Thank you for your order" message. Your script, eager to verify this, now tries to find that thank you message, and it fails. Why? Because its focus is still trapped inside the iframe. It's still inside that little payment world, and it's now blind to the main page where the thank you message appeared. This is where the second half of the magic comes in. You need an escape plan. After you're done working inside the iframe, you must explicitly tell Selenium to return its focus to the main page. The command for this is driver.switchTo.defaultContent. This is your return home button. It pulls Selenium's context out of the iframe and places it right back on the main document, where it can see everything else again. The proper workflow is always switch into the frame, perform your actions, and then switch back out to the default content. Forgetting that last step is one of the most common mistakes beginners make. Mastering iframes is a huge step, but the web is even more complex. What happens when you click a link and it doesn't just load content in a frame, but opens an entirely new browser tab or a new pop-up window? This happens all the time. You click Login with Google, and a new, smaller window pops up for you to enter your Google credentials. You click a Read Our Privacy Policy link, and it opens in a new tab so you don't lose your place on the main site. Just like with the frames, Selenium's default behavior is to be completely oblivious to these new windows. Its focus remains stubbornly on the original tab it started in. You can click a link that opens 10 new tabs, and Selenium will still only be aware of that first one. So, how do we manage these multiple parallel worlds? The concept is similar to a frames, but the mechanism is different. We use something called window handles. A window handle is a unique string of letters and numbers that Selenium assigns to every single window and tab it has open. Think of it as a unique session ID, or a mailing address for each window. The process for handling a new window looks like this. First, before you click the link that opens the new window, you need to get the handle of your current original window and store it in a variable. You'd say something like string original window handle equals driver.getWindowHandle. This is like writing down your home address before you leave on a trip, so you know how to get back. Next, you perform the action that opens the new window. You click the button or the link. Now a new window exists, but Selenium's focus hasn't moved. To find that new window, you ask the driver for a list of all the window handles it currently knows about, using driver.getWindowHandles. This returns a set of all the unique handles. In our case, it will contain the handle for the original window and the handle for the brand new one. Your job is then to loop through this set of handles and find the one that is not your original handle. That's your new window. Once you've identified the new window's handle, you use the command driver.switch_to.window new window handle. And just like that, Selenium's focus teleports from the original tab to the new pop-up or tab. You are now in control of that new window. You can interact with its elements, fill out the Google login form, accept the privacy policy, whatever you need to do. And of course, you need a way back. When you're finished in the pop-up, you can close it with driver.close. This command closes the window that Selenium is currently focused on. But be careful. Closing the window doesn't automatically switch your focus back. Your script's focus is now in a void, pointing to a window that no longer exists. This will cause an error. So, after closing the pop-up, you must use your saved home address to switch back explicitly driver.switch_to.window original window handle. This ability to seamlessly switch between frames, tabs, and windows is what elevates a simple script into a robust, real-world automation test. It's the difference between testing a simple static web page from the 90s and testing the dynamic, complex, multi-layered applications that run our lives today. We've taught our script patience with weights, and now we've given it dimensional awareness. It can navigate the intricate architecture of the modern web. But there's another layer of user interaction, one that's less about structure and more about nuance and dexterity. What about actions like dragging an item from one list to another? Or hovering your mouse over a menu to make it appear? Or right-clicking to open a context menu? These are the subtle physical gestures we perform without thinking, and our scripts need to be able to perform them too. To do that, we need to move beyond simple clicks and keystrokes and enter the world of advanced user interactions. Selenium gives us a powerful tool for this, a special class called appropriately the Actions class. Think of it as giving your script a pair of phantom hands. Instead of just teleporting the cursor to an element and instantly clicking, the Actions class lets you build a sequence of more human-like movements. You can tell it to move the mouse to an element, pause, hold the button down, drag it across the screen, and then release. You're not just issuing a single command, you're choreographing a performance. And this is a critical distinction that interviewers will probe for. They want to know if you can just follow a simple script or if you can actually analyze and replicate complex user behavior. So how does it work? First, you create an instance of the Actions class, passing your WebDriver instance into it. This essentially links those phantom hands to your specific browser session. From there, you start building a chain of commands. Let's take the most common example, the hover-activated menu. You've seen these 1,000 times. A top-level menu item like products or services that does absolutely nothing when you click it. But when you simply move your mouse over it, a beautiful drop-down menu appears with all the real links. A simple .click command is useless here. The element you actually want to click doesn't even exist in the DOM until you perform that hover action. This is where the Actions class shines. You would tell it, actions.moveToElement, the menu element. This command tells Selenium, hey, just move the virtual mouse cursor and hover it right over the center of this specific menu element. But here's the catch, and it's a mistake every single person makes when they first start. Nothing happens yet. You've only described the action you want to perform. You've put it in the queue, but you haven't given the final order to execute. To do that, you have to add .perform at the end of your chain. So the full sequence is: find the element, create the actions object, build the action like actions.moveToElement, the menu element, and then call .perform. That .perform method is the magic word. It's the go command that executes the entire sequence you've built. Once you perform that hover, the drop-down menu appears. Its elements are now present in the DOM, and you can proceed to interact with them as normal. Mastering this single concept, the build and perform pattern, unlocks a huge percentage of modern web applications that are simply untestable with basic clicks. But hovering is just the beginning. What about drag and drop? Think about modern project management tools like Trello or Jira, or even a simple file uploader where you drag a file from your desktop into the browser. How do you automate that? The Actions class gives us two ways to handle this. The simple way is a dedicated method, actions.dragAndDrop, source element, target element, .perform. You find the element you want to drag, you find the drop zone where you want to release it, and you pass them both into this method. It's clean, it's readable, and it works beautifully for most standard drag-and-drop interfaces. But what if the interaction is more complex? What if you need to drag an item, hover over a specific spot to trigger another event, and then drop it? The simple drag-and-drop method isn't granular enough. This is where you use the more fundamental building blocks. You can chain them together to create a custom drag-and-drop sequence. It would look something like this: actions.clickandhold, source element. This is like you physically pressing down the mouse button and not letting go. Then you chain.moveToElement, target element. This simulates you dragging the mouse, while still holding the button, over to the drop zone. And finally, you finish with .release, .perform. The .release command simulates you letting go of the mouse button, completing the drop. This sequence, click and hold, move, release, gives you surgical precision. You can insert other actions in the middle of that chain if you need to. This level of control is what separates a fragile script from a robust automation suite. It's the difference between telling your bot, move this from A to B, and giving it the fine motor skills to actually pick it up, carry it across the room, and place it down gently. And what about the other mouse button? The right click. Many applications have custom context menus that appear when you right-click on an element, offering options like delete, rename, or copy. How do you test that? You guessed it, the Actions class has a method for that. It's called .contextClick. You can use it like this: actions.contextClick, the element, .perform. This simulates a right-click on that element, which will trigger the context menu. From there, the menu becomes a visible element in the DOM, and you can use your standard locator strategies to find and click on the options within it. We also have .doubleClick. While less common, some interfaces use a double-click to enable an edit-in-place feature on a label, or to open a detailed view. It works exactly as you'd expect. Actions.doubleclick, the element, .perform. It's another tool in your arsenal for mimicking every possible way a user can interact with their mouse. The true power, however, comes from chaining these actions into a single fluid command. Imagine a scenario. You need to hover over a main menu, which reveals a submenu. Then you need to move the mouse down to a specific item in that submenu, which reveals a third-level menu. Finally, you need to click an option in that third menu. A novice might try to do this in 3 separate steps with pauses in between, hoping the timing works out. This is flaky and prone to error. A pro uses the Actions class to compose a symphony. The code would look like one beautiful, readable line: actions.moveToElement, main menu, .moveToElement, submenu, .click, final menu item, .perform. See what happened there? We created a single atomic transaction. Move here, then move there, then click. The .perform at the end executes the entire ballet in one go. It's faster, more reliable, and it clearly documents the complex user journey you're trying to automate. And the Actions class isn't just for the mouse. It also handles advanced keyboard interactions. Sure, Send keys is great for typing text into a field. But what if you need to simulate holding down the Shift key while typing to select text? Or holding down Control to click multiple items in a list? The Actions class has methods like key down and key up. For example, to type hello in all caps, you could do actions.keydown keys.shift .send keys hello. .keyup, keys.shift, .perform. You're telling the browser to press and hold the shift key, type the letters, and then release the shift key. This is absolutely essential for testing keyboard shortcuts, complex data entry forms, and accessibility features. You're no longer just a typist, you're a power user, and you can teach your automation to be one too. When you walk into a job interview and they hit you with a scenario question like, we have a data visualization tool where users can drag a slider to change the date range, and then right-click on the chart to export the data. How would you automate a test for that? You don't panic. You smile. You talk about the actions class. You explain how you'd use click and hold and move by offset to manipulate the slider with precision. You describe using context click to open the export menu. You show them you don't just know the commands. You understand how to deconstruct a complex human interaction into a reliable, automated sequence. This is the stuff that gets you hired. This is what demonstrates you can handle the dynamic, interactive, JavaScript-heavy applications that are the standard in today's market. You're not just testing if a button exists, you're testing the experience of using the application. Now that we have full control over how our script interacts with the elements inside the web page, there's one final frontier to conquer. It's the browser itself. What happens when your application opens a new window or a new tab? How do you switch between them? How do you take screenshots for your test reports to prove a bug exists? And for the ultimate pro move, how do you run all of this without even seeing a browser on the screen, making your tests faster and more efficient for a professional CI/CD pipeline? To do that, we need to learn how to manipulate the WebDriver in the browser environment itself. This is where the magic really happens. We're talking about running our entire test suite without a single browser window popping up on our screen. This is called headless execution, and it's the standard for professional automation environments. Why? 3 reasons: speed, efficiency, and necessity. Headless browsers don't have to waste resources rendering the visual components of a web page, the pixels, the layout, the CSS animations. They just process the underlying HTML and DOM. This makes them significantly faster. And when you have hundreds or even thousands of tests to run, every second saved adds up. Second, efficiency. You can run multiple headless tests in the background on your machine while you continue to work on other things, without a dozen browser windows fighting for your attention. And finally, necessity. The servers that run our automated tests as part of a CI/CD pipeline, machines running Jenkins, GitLab, or GitHub Actions, often don't have a graphical user interface at all. They are command line based. You can't launch a visible browser on them. You must run headless. So how do we do it? We do it by using something called options. Every major browser driver, Chrome driver, Firefox driver, Edge driver, has a corresponding options class. For Chrome, it's Chrome options. For Firefox, it's Firefox options. These classes are like a control panel for the browser before it even launches. You can use them to set preferences, add extensions, disable pop-ups, and most importantly, specify launch arguments. To run Chrome in headless mode, you create an instance of Chrome options. Then, you use its add arguments method to pass in the string, headless. It's that simple. It's a command line flag that tells the Chrome browser executable to run without its UI. After you've configured your options object, you simply pass it into the constructor when you initialize your WebDriver. So instead of just new Chrome driver, it becomes new Chrome driver, my Chrome options. Now, when you run your test, nothing will appear on screen. Your console or terminal will still show the test output, telling you if it passed or failed, but the browser will do all its work invisibly in the background. This is a game changer, but it also introduces a new challenge: debugging. If a test fails, you can't see what the browser was doing at the moment of failure. That's why many headless arguments are paired with another one, like window size equals 1920, 1080, to ensure the virtual window is large enough to render all elements correctly. And you'll often add a feature to your framework to take a screenshot on failure. Selenium has a built-in capability to take screenshots, and in headless mode, it will capture what the browser would have rendered. This screenshot becomes your eyes, an invaluable artifact for debugging a failed test in your CI/CD pipeline. And that brings us to the ultimate destination for our scripts, the CI/CD pipeline. Continuous integration and continuous deployment. This is the heart of modern software development, the engine of DevOps. And your Selenium scripts are the high-octane fuel that powers its quality checks. Picture this. A developer on your team finishes a new feature. They write their code and push it to a central repository like GitHub. The moment that code arrives, an automated process kicks off on a server. First, the server builds the application, compiling all the code. If that succeeds, it deploys the new version of the application to a dedicated testing environment. And then it's your turn. The pipeline automatically triggers your Selenium test suite. Your code, your page object model, your explicit weights, everything you've built now runs against this brand new version of the software headlessly on that server. It systematically validates the login process. It confirms the new feature works as expected. It runs regression tests to make sure the developer's changes didn't accidentally break something else in a totally different part of the application. If all your tests pass, the pipeline glows green. The code is deemed high quality and safe. It can then be automatically deployed for users, or at the very least flagged as ready for release. But if even one of your tests fails, the pipeline stops dead. It turns red. The developer is immediately notified that their change broke something. The faulty code is prevented from ever reaching customers. In this scenario, you are not just a tester. You are the automated gatekeeper of quality. Your scripts are the immune system for the entire application, constantly watching, constantly verifying, and protecting the user experience. This is why companies are paying six figures for Selenium automation skills. They aren't paying you to click buttons. They are paying you to build this automated fortress of quality that enables the entire company to move faster and with more confidence. And with that, you have seen the entire journey. We started with the simple act of locating a single element on a page. From there, we learned to interact with it to handle different types of elements from drop-downs to alerts. We mastered weights, understanding the critical difference between a static sleep and a dynamic, intelligent weight. We architected our code using the page object model, transforming a messy script into a clean, reusable, and maintainable framework. And now we've configured it to run headlessly inside a professional CI/CD pipeline, the pinnacle of modern test automation. You now have the foundational knowledge that underpins the vast majority of UI automation jobs in the United States. But this is not the end. This is the launchpad. Where do you go from here to become a top-tier candidate? First, dive deeper into a testing framework. In the Java world, that's TestNG or JUnit. In Python, it's PyTest. These frameworks are what you'll use to actually manage your test suite. They provide annotations to define tests, hooks to run setup and teardown code, powerful assertion libraries to verify outcomes, and most importantly, they generate detailed test reports. Learning a framework is non-negotiable. Second, learn about parallel execution with Selenium Grid or cloud-based services like Sauce Labs or Browser Stack. Running one test at a time is fine for a small suite, but what happens when you have 500 tests that take 10 hours to run sequentially? You can't have your development team waiting that long for feedback. The solution is to run them in parallel. Selenium Grid allows you to set up a hub that distributes your tests across multiple machines, or nodes, running different browsers and operating systems, slashing your execution time from hours to minutes. Third, expand your automation skill set beyond the UI. While UI testing is critical, it can be slow and sometimes brittle. Many checks can be performed much more quickly and reliably at the API layer. Learning how to automate API tests using tools like Postman or libraries like Rest Assured for Java will make you an incredibly versatile and valuable engineer. A professional who can write UI, API, and even performance tests is the complete package. And finally, never forget the soft skills. Your technical ability will get you the interview, but your communication skills will get you the job and the promotion. Learn how to write a clear, concise bug report that a developer can actually use. Learn how to explain a complex technical problem to a non-technical manager. Learn to collaborate, to ask good questions, and to understand the business goals behind the software you're testing. The path you've started on is one of the most in-demand and rewarding in the tech industry. You've taken the first, most difficult steps. The next step is to build. Don't just watch tutorials. Apply what you've learned. Pick a complex, real-world website, an e-commerce site, a social media platform, a travel booking engine, and build an automation framework for it from scratch. This project will become your portfolio. It's the proof that you don't just know the theory. You can deliver a working solution. Your GitHub repository with this project is more powerful than any certificate. You have the roadmap. You have the foundational skills. The demand for what you know is immense, and it is not going away. Every company pushing software needs people like you to ensure their products work. The journey from manual quality assurance to an automation architect, from a job to a career, starts with a single line of code you choose to write today. Go build something amazing.